All right, so let me go over some details here. Let's go back to, I already discussed the face mill. Let's look at this one here, but I'm going to put it back in the wear compensation, because this is the tool path where it's going to go method. So we need a, personally, I select up in the upper right corner, so it's not that important. So if this is our x0, y0 right here, then I would call this like real simple, like x minus 1.0 and y positive 1.0. In this case, let's see, let's pull our print up here. Print. All right, here's our print, right? 3 inches. So if I went to do just like what is on the screen there, I would go to x 1.5 and somewhere up here like y 1.0. And then I would go to this y0 coordinate and turn on my cutter comp and go to these positions. Boom, 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 and then cross the fin and go around the corner. And then if I'm doing it around here, I call it crossing the finish line. But over here, we'll just go over here, and then we'll start up here. Actually, I think I can. I think I'm going to reprogram this so it does it the way I want it to. So geometry, selection. I'm going to rechain. And I'm going to select, where is it now? Oh, crap. It's metric. All right. Yeah, it's going to be this profile here. And I need to start at the beginning. Where the heck is that selection? Lead in and out, I think. Oh, excuse me. Midpoint. We don't do midpoint. I'm going to go start over here. I'm going to regenerate. I hit top view. All right, there. That's how I usually manually program these things. And I'm going to add in a. Let's see. Length 200. I'm going to do a 90-degree angle. So I'm going to make this, how do we do that now? Tangent. Not perpendicular. It should be perpendicular. And, nope, that didn't do it. Okay, I'm back. I fixed it the way I wanted to. I'm going to start in the upper right corner here. Okay, so this will be my start point, and the yellow lines actually represent the rapid moves. And I'm going to feed down to the bottom of 375 and go a little bit more and walk around this. So I'm going to hit top and let's replay this again. Hit verify and play. Oh, there we go. Goes around, and across the finish line and shut the compensation off. So let me backtrack this. Step back. Okay, let me zoom up a little bit here. All right, so let's call this x minus 1 and y positive 1. That's our start position. If you follow Mark's first 9 lines, it's going to be, you got to put the position in there. Then we're going to go step by step. I'm going to do a little angle here. All right, comes down, and now we're at cutting depth. That's going to be a G1 move to go down. This one here is the move you need to turn on cutter compensation. So as you're approaching Y0, which is here, you're going to say, in this case, this is tool 2, you're going to say, turn on the cutter compensation value that I have in the tool offset page. But I'm using Y0 as the coordinate. If I did not do that, this tool would be right over the middle of this, and this would be way too small. Let's go to the next step. Then I'm going to say, go to this corner coordinate, which is X3 and Y0. right there. But in reality, it's at X, I wish I put a half-inch end mill here. I could probably change it. It's 3 inches plus 1.875, 3.187. That's where it actually ends up, because it's taking this coordinate and adding it to it. And as we're going in here, we're using G41, and we always use G41 because we always want to climb mill. Left is climb milling side. We rarely use G42. It's going to compensate. Even when you're coming in this tray, it's looking ahead. It's looking ahead. It's like a Swami. So, okay. And I'm going to go down here, and up here, and cross the finish line. We made a nice rectangle. And then we have to shut the compensation off. And that's this last move. And I just go back to the same position. It's pretty basic. Okay. And then the drill cycle. I'm going to turn off this tool path and turn on this one. All right. Let's go back to simulation, backplot. And this is a 90-degree tool. Typical spotting drill for your soft metals. All right, how deep do we go? You know, if you have the little Haas mini book that they give you, like there's actually a page in there that you can do quick calculations of like 82 degrees or 90 degrees or 118 degrees. How, you know, that's for your normal drills. But a 90-degree tool is a pretty typical spotting drill, they call it. And a lot of us like to get the spotting drill to spot and leave us a little chamfer, so we don't have to come back with a chamfering tool. But you're prepping to run the big drill through it. So how deep do you go? 90 degree is actually pretty simple. It's if this hole was 250 diameter, according to the print, right? I don't know what size they are on there, but I think I looked it up. It was 250. Then it's actually not even the it's the Pythagorean theorem, but it's half as deep as it is wide. That's going to be your Z. And if you're calling the top Z0, to make this 250 wide, you would go 125 deep. That would be your Z. All right, hit play. Let me leave the verify on. Oh, I guess it doesn't do it now. One step at a time. So this would be your can cycle, we call. Literally in the background, it's running G1s and G0s, and you can literally program it longhand. I think back in the late 70s, they were doing it like that before they came up with the can cycle. If you want a history lesson, but so it would rapidly go to position, and then it would, if it's up here, you might rapidly go to just above it, which is an R level. And then you feed to the depth you want, and then you got to decide where you're going to return to. That's the G98, 99. And if you watch the video with the carbide end mill that breaks, a drill that breaks, if you need to return high, you would need, that would be the initial position, and that would be G98. If you say G99, it's going to return to the R position if they're different, you know. So normally, especially if you want to jump over clamps, but if you use G98, it's always the safer selection.